Hi, I welcome you back to this course, Complete Python Bootcamp. Now we have next in our list is the bitwise operator and the last operator so far in the series. So now you are familiarizing these operators with the logical operators that we have already discussed, but these are a little bit different and they work as the bits. They work on the bits, not as a complete, you can say, not on a complete number. So now you must be getting confused. What is bit? What is number? So let me give you an example. There is, you can say, the whole number series system, and whatever digits we have that are in the decimal numbers 0, 1, 2, 3, 4, 5. These all are considered as the decimal numbers. But do you know computer doesn't understand these numbers? Computers only understands the binary numbers, and binary numbers are only 0 and 1. So if we want to convert every decimal number to the binary numbers, the computer has its whole system to do that. And like whatever values that we are passing to our variables, such as 6, 7, all are converted to the binary numbers at the back end when the code is getting compiled. So are you interested in knowing how these operations or how decimal numbers are converted to binary numbers? So I'm giving you just an example here and teaching you how you can simply see, like, if a 4-bit number you want to convert, how it is done that. So for that you must know some of the mathematical rules of these notations that I have presented here. So this first value that I'm highlighting, this stands for 2 raised to the power 0, and any number raised to the power 0 is always be 1. Now this second number represents here is 2 raised to the power 1, which is the value which is 2. And for this, uh, if I tell you what it is 2 raised to the power 2, which is 4. We all know that 2 raised to the power 2 is 4. So now if I want you to have the numbers from 0 to 7, how you will present that? So the first numbers from 1 to 7, sorry. So first number is 1. So you know that 2 raised to the power is 1. So I will write 1 here and 0, 0 to these values. So this is the number 1. Now I want to write this decimal number 2 in the binary format. So I know that this value corresponds to the 2. So I will do 0. I know here it is present 1, and I will again mark it as 0. So this is my decimal number 2. Now I want for 3. So I know 3 is 2 raised to the power 1 is 2, and 2 raised to the power 0 is 1. And if these both bits are 1, 1, then it's corresponding the value of 3. So this corresponds to the decimal number 3. I will do till the 5, as I have one example to show you. So now 4. Now we know that this value corresponds to 4. So what I will do is I will mark it as 1. All other 2 bits as 0, 0. Okay. So this is my 4 and last 5. So I know this is 4 and this is 1. So I will mark it as 1. This is my 0 and this is my 1. So this is my 5. Similarly for 6, you know 2 raised to the power 2 is 4 and plus 2 is 6. So 110, and for 7 it is 111. So now you have understood how we convert. So these bitwise operators work on the bits, while the logical operators, I'm sorry, I need to convert it into the, you can say, heading. Yeah. So you understood the process. So now if I am giving a variable x as 4 and other y as 5, so now if I am doing x And this is my logical operators. Okay, because bitwise operators are denoted by this symbol and this pipe symbol for or, and all other XOR not. So this is my logical or logical and now if I do that, I get as my answer 5, because it is comparing 4 and 5, like both are above than 1, and it is like true and true, which is giving me the value of true. If I assign any value to 0, my answer will become 0, because it is like true and false, which is, sorry, yeah, true and false. It is always be my false, so 0. So I'm now again keeping my y as 5, and it is like 5. And now if I do the bitwise operation, that is x and y, the symbol operator of and, now I get my answer as 4. So it is comparing bit by bit. So if I compare 0 and 1, the result will be, sorry, 4 and 5 I need to compare. So 1 and 1, 1 is compared with 1. So 1 and 1 is always be 1. So I'm getting 1. Again, 0 is compared with 0. So 0 and 0 is 0. 1 and 0 is 0. So I'm getting my answer as 100. So that's why it is returning me 4. I can compare it bit by bit. So next bit is 0 and 0, which is again 0. And the next bit I need to compare for 4 and 5 is 0 and 1. 0 and 1. That is again 0. So I'm getting an answer 1 0 0, and it is represented as 4 in decimal number. That's why I'm getting an answer as 4. You can try it. If I make it y as 2, will remain 2. Now my value changes to 0. Now you can compare the 4 and 2. So this is my 4 and this is my 2. So 1 and 0 is 0, 0 and 1 is 0, 0 and 0 is 0. So that's why I'm getting an answer of 1 and x and y now as 0. So hope you understand that bitwise operations are done like bit by bit. You have to first convert your number, like it is converted into decimal, into binary number, and then it is compared. So these are not mostly used in like in the Python, but yeah, you should know that how it works.